So good afternoon, good morning, depending on where you're calling from. Welcome to today's live session with Victoria Nyaga. She'll present on land degradation. The session is recorded and we'll be able to share the recording, and any questions are welcome thereafter. So welcoming Victoria, our own scientist. Thank you so much, Victoria.
Thank you. Land degradation notebooks we've been working with OSS, and the goal of these notebooks is to see how land has changed over time using the land use land cover data sets that we have, and also using the NDVI. So starting off, we'll first be cleaning up our data for the land cover classification, and the area of interest for this notebook is Burkina Faso. So in the first step, you'll notice I won't be running the cells during this notebook because I've already pre-run the notebook to save on time. So we'll start off with the Python, loading the necessary Python packages. Then in the next step, we will be connecting to the data cube and defining the analysis parameters. You'll notice that it follows the same format that we use in the other notebooks, where we have our getting started section, and we'll also include in this section selecting our country of interest. Like I mentioned, this is going to be Burkina Faso. So you can see the list of other countries based on our shapefile that we can use in this notebook to run the analysis. Next up, we are going to load the ESAL Climate Change Initiative land cover dataset at 300 meters resolution. After we load it, we want to mask it with the country polygon that we loaded in the analysis in this section. And then we're going to mask the data set using the country polygon to ensure that the boundary, all the data is loaded within the boundary of our polygon. We also have a section here where we can load we can export each data set for each year as a single GeoTIFF. This is loaded into when you run the notebook into your results folder. So you will see following this file name sequence, the results 2014, 2015, and 2019. This fits in with the time period of analysis that we loaded in previously. Next up, we're going to have a few parameters we set in for how we plot our data. So this dictionary is just to define the color for our legend. We also define the figure length and the number of columns, and also add in a north arrow and a scale bar for our plots. Next up, we're going to plot this CCI land cover as is. And as you can see, if you zoom in, each plot has a scale bar, and also the entire figure has a north arrow. So you can see the CCI land cover for Burkina Faso from 2014 all the way to 2019. Once we've loaded in the land cover, we want to reclassify it into the 7 land use and land cover categories that we have here. This one will enable us to define land degradation better. So we have the class names, that's the labels, we have the values, and we also have the colors we'll assign to each of these land cover classes. Next up, we want to classify each unique pixel value in the CCI land cover dataset to match one of the new land cover categories. So we have the treed areas, prairies, cultivated land, wetlands, artificial surfaces, other land and water bodies. These are the new 7 land cover class categories. And on this side, we have the unique class values for the CCI land cover dataset. We define our reclassification condition here and create a new X-ray data array that has our new 7 land use land cover categories. As we did before, we can also export for each year, each land cover image as a geotiff. And then we can also plot for each year the new reclassified land use land cover dataset. So you can see here we have for each class the accompanying color. So we have the water bodies, other lands, artificial surfaces, wetlands, cultivated land, prairies, and treed areas. And for each year from 2014 to 2019. We can also produce an animation for that for the new reclassified dataset. And you can also view how each land cover class or all the land cover classes change over the years using bar graphs. So for this next section, we are producing a data frame that shows the area in hectares for each land cover class for each year, for each specified year that we loaded the data for. We can export this as a CSV for further analysis later. We can also view each bar graph in this section. So we have, we can see how each land cover class trend was for each year. We can also view specifically for one land cover class for all the years. So we can view how the treed areas changed over the course of 2014 to 2019, and for the other 6 land cover land use categories. Next up, we have the change detection. So we want to see, we classify change as either bad change, stable, or excellent, and assign the colors red, orange, and green when we plot the change over the years. If you notice, I'll go back to the analysis section. We chose our base year as 2015. Sorry, yes, we chose the initial year as 2015 and the follow-up year, the year for which we'll detect if change has occurred, as 2019. So that's what we're going to be using in this change detection section. Now in this, we loaded the land use land cover data set and selected for each year that we specified. And then we defined in this section what classifies as stable change, what classifies as bad change, and what can be classified as excellent change. An example is we chose treed areas to prairies and wetlands to cultivated land as negative or bad changes. And then we considered changes like prairies to treed areas, artificial surfaces to treed areas, or other land to treat areas as positive or excellent changes. After creating our change data set, we can export it as a geotiff and also plot it in this section where we have the 2015 to 2019 Burkina Faso land use land cover change detection. And we can see majority of the areas were considered stable. That means that no notable change occurred. Then we have the green areas, which are excellent or good or positive changes that we have. And we also have the bad or negative changes that for the land cover data set. We can also quantify how much each change was in hectares. So we have this data frame showing the bad, stable, and excellent changes in hectares, and we can also compare them in a bar graph. And as you can see here, the most notable change was a stable, which a majority of pixels remained relatively in the same land cover category. We also produced an area change matrix just to show, give a clearer picture of what we are looking at. So we can see from 2015 to 2019 for Burkina Faso, the land cover land use zone change matrix, that is the changes in hectares. And we can see here for the treed areas, two treed areas or remained treed areas for 2015 and 2019. We can see the area in hectares, and we using the color codes, we can determine whether the change was stable, which is orange, excellent or positive, which is green, and negative or bad, which is red. So this gives a clearer picture of how the land use land cover categories changed for the different years we choose. If you wish to find for different areas or different time periods, all you have to do is, once we publish the notebooks, is change these parameters. So this is a time period of interest that will load data for, and then you can select your own base year or initial year, and then the follow-up year for which to detect change. Next up, we'll go to the NDVI change detection. So all the notebooks follow the same format. We have the loading in the necessary packages. The only difference here is we'll be using the DAS cluster to ease up loading and analysis for our NDVI data. The area, the time period of interest and the initial and follow-up year are the same, and we'll also load the resolution to be the same as the CCI, even though the NDVI is available at 30-meter resolution. For consistency, we will keep the resolution the same at 300. So the same, our area of interest is still the same country, Burkina Faso. So we load in the Landsat annual geomat data for Burkina Faso. We'll also mask it using the country polygon and then calculate the NDVI spectral index here. We can export the NDVI. We can export the NDVI data set as for each year as a geotiff, and also plot the trend. Also plot the trend over time. Next up, we can plot our NDVI dataset for 2014 to 2019 for Burkina Faso. As you can see here, majority falls in the green area, which is this range from 0.2 to 0.8. For the NDVI, we wanted to reclassify them into 5 different categories, being the very low, low, normal, high, and very high NDVI. So we specified the class labels here and the class values, and also the colors that we'll use to plot the data set. As we did in the previous notebook, we specify our conditions here for the reclassification, and then based on our NDVI data set, we reclassify it into the classes that we wish to see. For the reclassified data set, we also export it as a geotiff for each year, and also plot it as an image using matplotlib in this section. So notice we have now our five different classes, that is very low, low, normal, high, and very high. And for each year, we plot the NDVI classification for Burkina Faso. A majority of the areas seem to be in the low section, as you noticed by the slightly orange color of the pixels. We can also plot an animation showing the trend over the years, and also view how for each individual NDVI class, what the area in hectares was. We also have a bar graph showing the same for all years, comparing the classes in a single year, and also have bar graphs plotting for each classes over all the years of available data. So we have for the very low and the low, you can see the trend from 2014 to 2019. Next up, we have the change detection using our initial and follow-up year. In this case, we specified what we consider to be the stable changes, or the bad or negative changes, and the excellent or positive changes. So for example, A negative change could be low to very low for the NDVI classification, or very high to very low. An example of a positive change could be the very low to the low, and also normal to very high or high to very high. So using those conditions, we created our change data set, and we also exported it as a geotiff. You can see the plot where we have our excellent, stable, or bad changes, and you can see majority of the area remains stable, and which is the orange pixels, and then we have the bad changes, as you can see here, the red, and the excellent changes from 2015 to 2019 in the green. We also created area change matrix just to give a clearer picture of how these changes occurred for the initial and follow-up year. So we can see, for example, the low to classes that were pixels that were low in 2015 and became normal in 2019. You can see the area in hectares. So that's 417,888 hectares. And we can see it's in the green color code. So this is defined as an excellent or positive change. Finally, we come to the cross LULC zone change and NDVI zone change matrix, in which we compare the results we got for the land use, land cover, and the NDVI change detection. In this case, we load the exported change detection images that we exported from our previous notebooks. Then we choose the conditions for our comparison. So we have the mediocre class, the bad, the stable, the good, and the excellent in increasing like a positivity. So also define the class values and the colors we'll use to plot once we get the data, we create our data set. So how we compared is to get the LULC change and the NDVI change, add them, and divide them by 2. So once we got our data set for the comparing the two change arrays, we exported it as a geotiff, and then we also plotted it. So here we can see, this is what we can consider our land degradation map. So we have our mediocre, which is red, the red areas, which are not very prominent in our map. And then we have what we considered bad changes, and that's the orange areas in our map. And then we have stable, which seems to be the majority class, which is that relatively we do not consider any change occurred. Then we have the good and the excellent. So the good is a slightly lighter green, and then we have the excellent in a few places, which is the darker green. So this is our cross LULC NDVI change map, can also be considered our land degradation map. For greater clarity, we also have a zone matrix, as we did for the other 2 notebooks, where we compare the LULC change matrix and the NDVI. So we can see the areas that are considered bad by both change data sets, that's the LULC and the NDVI. We see the area in hectares, and we also have the color code stipulating whether it is a mediocre, bad, good, or excellent class. I think that's it for my presentation. Are there any questions?